Welcome to the Oracle GoldenGate YouTube video series. Oracle GoldenGate is the industry's premier multi-cloud technology for building real-time data fabrics, data mesh, and data replication solutions. With class-leading, high-throughput, and extremely low-latency streaming data, Oracle GoldenGate is in a league of its own. Thousands of customers in over 180 countries globally trust GoldenGate with their most important data, and GoldenGate is consistently rated as a top leader for data integration and enterprise data fabrics. One key reason that GoldenGate is one of the most successful integration tools in history is the consistent innovation over more than 20 years. GoldenGate has notched many industry firsts for modern event-driven streaming data solutions. Oracle GoldenGate is first and foremost known for its data event capabilities, including long-time leadership for data high availability, transaction replication, and change data capture. More recently, since 2015, the most successful areas of GoldenGate have been in the areas of data pipelines and stream analytics. Modern technology solutions demand real-time data ingestion, streaming ETL for low latencies, and best-of-breed analytics on data in motion. GoldenGate delivers modern time series analysis in a no-code development package with enterprise-class data governance, including best-in-class data security, data verification, and a rich metadata catalog. Another reason that GoldenGate is so successful is that it is truly a tool for all enterprises, supporting a huge variety of common databases, applications, NoSQL data stores, clouds, and messaging systems in a powerful low-latency data fabric. GoldenGate's modern microservices architecture is the foundation of real-time data events for the event-driven business. With an easy-to-use browser-based user interface and available cloud services for just pennies per hour, there's nothing stopping you from realizing the future today. Try GoldenGate for free. Follow this link for more information. And now, onwards to the video you came for. I wanted to introduce everybody over to this idea of a decentralized mesh of GoldenGate deployments relative to a centralized hub of GoldenGate deployments. And so GoldenGate is one of these tools that can do a little bit of both. And one of the things that I think is really quite interesting is for all of us on the phone today, certainly, anybody who's in a session like this, for our entire IT careers, the computing environments, the enterprise computing environments that we've worked with have all essentially been centralized monolithic hubs, from mainframe hubs to, VAX and DEC minis to ERP systems of the 90s and the monolithic applications that kind of were rolled out then. Even Kimball and Inman style, data warehousing and this kind of centralized models for doing data warehousing. And then, of course, with the emergence of big data and even cloud-based data lakes, all kind of more centralized and monolithic in nature. But what's really fascinating in the industry right now is not just in IT, but in the world in general, there's this massive mega trend happening towards decentralization of everything. Decentralized finance with crypto. We're seeing kind of spin-outs proliferate from large multinational organizations or decentralized organizations, so that kind of restructuring towards divestitures is happening. We've seen, of course, already the rise of decentralized service mesh architectures for what's universally considered to be modern application development architectures these days with microservices and service mesh. We're seeing kind of decentralized Wi-Fi, decentralized smart homes, decentralized telecommunications with 5G and 6G technologies. And so there's this big mega trend happening in really almost all aspects of our individual as well as professional lives around decentralization. And it kind of begs the question, why would data be affected by this? What's the driving motivation for decentralizing data? The first thing to note is that technology architectures inside of our own companies and our clients in some cases really are often a mirror of the people organizations or how those businesses and business units are structured. And so what we see is the data itself, the applications, and the IT environments are decentralized just as the organizations are. They're often a reflection of that decentralized infrastructure ownership that happens. We also see and Mark and Peter were just talking about it, the demands that rise from multi-cloud environments. And, sadly, not all multi-cloud requirements are actually by design. In many cases, it's more of an emergent trend that's happening as different lines of business and business units begin to adopt public cloud computing. It further kind of decentralizes data without necessarily having centralized governance. We also see the rise of global operations and that tension from a global operations standpoint with the need to balance local regulatory compliance. And so you heard about the global data services capabilities that is often used in combination with data sharding at a database level, again, reflecting the need to keep data privacy rules in place by geography or physical geography. But the applications themselves are distributed. So the applications may run at a global scale or even for high availability purposes across cloud regions or even across country boundaries. We also see the need to drive innovation and agility. And so this is really an important one. If you think about it, this is the entire reason that we've seen the microservices and service mesh architectures take off in app dev is the need to drive a more agile way of doing DevOps and a more agile way of driving continuous integration and continuous delivery for application updates. And similarly, we see for data-driven applications or data-driven analytics, a need to become more agile, to become more reactive to what's going on in the world of the data. And so that's why we see, again, these decentralized data architectures kind of taking hold, because they can be much more adaptive than more of a monolithic data architecture. And so what are these decentralized data solutions do best? I've already mentioned a few of them, hybrid cloud, multi-cloud, cross-regional, high availability and DR, like we just heard about from Peter, mixed heterogeneous use cases across databases and data stores, mixed heterogeneous use cases across applications, cloud applications, on-premise ERP applications and business processes, as well as involving now what's happening and exploding in all industries is the use of Internet of Things, the use of edge computing, the use of service mesh and serverless capabilities for app dev. So all of these big mega trends really reinforce the need for these distributed data solutions. And so, why do we use this word mesh? When we talk about distributed data, why are we talking about meshes? Why do we talk about data mesh? Why do we talk about service mesh, et cetera? Well, the word mesh means a specific thing, right? It means a non-hierarchical collection of nodes that work together. And the key thing is really the non-hierarchical, right? It's not a tree. It's not a hub and spoke. It's truly a mesh. It's a non-hierarchical collection that's working together collaboratively. And so the examples in all of our lives, 5G technology, now 6G, I'm talking to you right now from a Wi-Fi mesh in my house with multiple nodes on different floors of my home. I've got smart things, smart home mesh as well with low energy protocol smart things, or Z-Wave is one of them, but there's several others as well. And then, of course, in IT, we see the rise of microservices, service mesh, the kind of control plane, data plane architectures that we're seeing, which stem from what's called sidecar proxy, the rise of Kubernetes as a way of managing distributed services in pods or clusters. And so all of these are related to this word mesh. And, what we're really seeing is kind of the emergence of that architecture in the data landscape as well. But we're coming from a past that was actually quite different, right? Conventional data integration for all of our IT careers has been hub and spoke. It just has, that's a fact. And so hub and spoke architectures made a lot of sense when data was mostly on-prem, made a lot of sense when your big core monolithic applications like ERP systems and data warehouses were on premises. Data consolidation back in the old days was often done from a single kind of monolithic organization. It'd be like a mega IT project, to consolidate a data warehouse, or, to roll out an ERP system, or to apply data governance practices, et cetera. But, in a lot of ways, those days are long gone, right? We're not seeing kind of the drivers, the same drivers today that drove us towards the hub and spoke solutions in the past. And when you think about what the other guys are doing with their change data capture and replication tools, I guess I heard earlier that some of those other guys might be on this webinar with us right now. But what everybody else in the change data capture community is doing is they're essentially bringing a hub and spoke architecture, right? They connect to their sources either directly. Some vendors, not all of them, but some vendors have an option to deploy agents that can run on the source or the target. But the routing and the communications all done through the hub server. There's typically a metadata database that's required for that hub server. There's other functions that reside on the hub, like schedulers, logs, routers, et cetera. But everything kind of moves through that hub into the target space. And that creates a couple of problems for these kind of newer trends that are happening. It tends to require heavier mid-tier servers. There's a lot of inflexibility with regards to how the source data logs are accessed. Some of that's mitigated a little bit by the tools that do have an agent option, but for others, they need to co-locate the hubs very close to the source logs. It creates challenges in the cross-WAN environments where data needs to move across SQLnet or ODBC or JDBC. These tend to be very chatty protocols. It's the same reason you don't put your application in New York and your database in Seattle. You typically want your apps located close to their databases, and that's because these client protocols are very chatty. They create a lot of latency and a lot of lag when the transactions are flowing at volume. And it's the same thing for CDC tools that are set up this way, that there's going to be more lag, more latency. I'm not sure exactly what Peter ran into with the Informatica change data capture tool. I know on the Oracle side, they typically use LogMiner, or when they do make use of the binary logs that requires their hub to be co-located or mounted to that same drive that the database logs are running on. And that in turn can create a lot of round-trip latency, especially if it's JDBC protocols being used to push data up to a Hadoop environment, for example. Remote agents, often really just a Band-Aid to cover up some of the core performance issues that come with the hub and spoke architecture. And again, I mentioned, often for the Oracle databases in particular, most of these tools that are out there are using LogMiner. A handful of them have these sort of classic style, which is the old way that GoldenGate years and years ago used to connect to the binary logs of the source data store. So there's this kind of older technologies with older ways of connecting to the Oracle databases. And so with GoldenGate, what you're getting is a little bit different. It's actually a lot different. You get the ability to run it in a hub, which can make sense for certain use cases. I'll get into the pros and cons in just a minute. But importantly, you can also run GoldenGate as a mesh. And with that GoldenGate mesh, you can essentially distribute your microservices across different VCNs. So this mesh type of architecture is super critical for high availability disaster recovery, super critical for low latency replication. It's the reason why you see GoldenGate being used for these high availability and maximum availability use cases in places where other vendors just don't really do that. It's a lot easier to embed these mesh type microservices within modern app dev that are already microservices based. You don't have to introduce a hub just to run a microservice, right, essentially. It's a true non-hierarchical mesh of microservices. GoldenGate runs C-based microservices. There's no external database required for metadata. It's really, the purist out there that talk about microservices will tell you a true microservice shouldn't require a backing store. Essentially, and GoldenGate doesn't require a backing store. And these mesh use cases are critical for all of the long distance, low latency, high security scenarios for doing event transmission. Now, of course, you can deploy GoldenGate as a hub. Many people do. You're going to hear in Alex Lima's presentation tomorrow a lot more discussion around exactly how to set up and run GoldenGate as a hub. And there's some benefits to doing that. When you do that, essentially what you're doing is you're running multiple GoldenGate homes or multiple GoldenGate deployments within each home on a single server. And so you can set up as many extracts and replicates as you want, as many homes as you want, running on a single server, and you can essentially support your entire replication use cases, all sources, all targets, multiple jobs, if you will, for the replication frameworks, all running from a single host. And again, there's some benefits for that around lifecycle management and administration and monitoring are some of the key ones, but we'll talk a little bit more in just a moment about when it really makes sense to run as a hub. But the GoldenGate Mesh architecture, just to drill in a little bit more on that, it's these C-based microservices that get distributed across environments. So here we're looking at a hypothetical scenario where I've got on-prem environment with on-prem databases, maybe Exadatas. Then I've got some analytics running in Google with BigQuery, maybe Cloud SQL environment with Postgres in GCP. But then I've got another kind of node, GoldenGate, pushing some of those transactions into an AWS data lake environment that's running Snowflake, for example, in AWS. Oh, and then up here in the upper right-hand corner, maybe we've got a roving edge environment that's collecting, signal intelligence from semi-disconnected devices using our edge deployments for GoldenGate. But across all of these different environments, essentially what I'm running in each location is a GoldenGate process that does either the extract or the replicate process. And then I've got either a distribution service or a receiver service. And all of the data flows, the transactions that flow from on-prem to Google to AWS to the roving edge are happening over the native GoldenGate wire protocol. So that's the built-in protocol that GoldenGate ships with. It allows us to do that high-speed communication from infrastructure to infrastructure using just the microservices components. Again, no hubs, no backing stores, no heavyweight deployments. I can essentially distribute this as often or as far and wide as I want. It can all be node to node. The non-hierarchical part of this as well is that I can distribute DML events coming from my primary up here on the left over to a ledger that's running in GCP, and the distribution service, the GoldenGate distribution service that's looking at that trail or the ledger, the DML ledger we call trail, GoldenGate trail, can actually push those transactions along to the AWS environment. So we can do fan out, we can do propagation, we can do fan in, we can do any type of non-hierarchical communication. And this type of deployment with these lightweight microservices is really unique to GoldenGate. The value, as we talked about in my first session, is that everything that's flowing across the GoldenGate wire protocol, across this mesh, is trusted, consistent transactions. So we're moving the DML and the DDL at precise checkpoints, right? We're not losing data. We're keeping transactions together, and we're always maintaining the precise ordering of the source transactions, whether that's SCMs with Oracle databases or any source database. So across the road, we get consistent, precise transactions, really at planet scale in this global transaction mesh. And again, that gets back to this core concept of providing a global transaction mesh at scale where you can trust the data, you can trust the transactions as it's flowing between these environments at very low latencies. Really, in most cases, we can go as fast as the network can go. So the pros and cons at a high level, use that hub deployment style when you're prioritizing simplicity. If you want a single location for all your GoldenGate installs, if you want an easier lifecycle for patching and upgrading and providing automation all from a single server, the hub deployments are great for that. And then from a monitoring perspective, it kind of gives you that single point where you can go get telemetry from all your GoldenGate installs. You don't have to worry about monitoring a diverse set of deployments of GoldenGate. The cons, of course, from the hub deployments, you get the much heavier workloads on single servers, and you got suboptimal networking. I would really say in most cases where you've got those remote connections. For mesh deployments, really you want to be thinking about these decentralized mesh deployments when you need to operate at planet scale. And I would argue that what we heard from Peter at Lowe's is getting into planet scale, where you've got very high data volumes, you're moving transactions across longer distances. If you need to maximize performance, with the payments example that Mark gave, where you have cross region, AWS East to AWS West, and it's a high availability scenario, you need as low a latency transactions as possible. You want to do a mesh deployment. Modularity for cross VCN, cross cloud. For CI/CD agility, if you want to be able to do rolling upgrades and kind of bring up applications on one node at different versions and applications on another node, you can upgrade, patch, and maintain GoldenGate in a decentralized, agile way. And it's also better for embedding in these microservices apps. So for modernization initiatives where you're moving towards microservices as an application design framework and you want to embed microservice for change data capture, microservice mesh deployments are the way to go. Of course, the con from a mesh deployment, as we've discussed, is it does raise complexity. It's one of the things, if you go towards a mesh deployment, as with any distributed environment, it's non-trivial to manage that. And the same is true for service mesh. As you start to distribute microservices across Kubernetes nodes, across Docker containers, across cloud VCNs, it requires more work to stay on top of those kinds of deployments. So, the wildcard option, which is actually a great transition to Dennis, who's coming up next. The wildcard option is cloud native serverless, OCI GoldenGate. So you now have the option of getting Oracle Cloud Infrastructure GoldenGate running in a fully managed way. That way you don't have to deal with kind of the administrative ops side of maintaining, patching, and managing GoldenGate. And you can essentially run GoldenGate in either mode. You can run it as a hub, or you can run it as a mesh architecture. It just happens to be hosted as a fully managed environment inside Oracle Cloud Infrastructure. And you're about to hear a lot more about that from Dennis. So in summary, I realize I moved through this pretty quickly, but look, GoldenGate's the only tool that gives you an honest choice between a true mesh of C-based services with no backing store and a hub. And you can do both. You can do either. You can actually mix and match. They all work together. They're forwards and backwards compatible from a GoldenGate architecture. Use a hub when you're prioritizing simplicity. Use a mesh when your systems demand the best performance, or when you're embedding inside of a microservices-based application framework. And then again, the wildcard option is OCI GoldenGate. You can actually do both. You can do hubs, you can do mesh, and it's all fully managed by Oracle.